Assalamualaikum warahmatullahi wabarakatuh. I am Arif Iskandar bin student, student ID 18002402, Lab 3, and will present about control volume through observing impact of a jet. So, what is fluid motions? It's basically a natural or artificial system that may exert forces on objects that comes in contact with it. In order to analyze it, the fluid motion, a finite region of the fluid, which is the control volume, is usually selected and determined by calculating the net mass rate that flows into it and out of the control volume. This process can be determined, as in solid mechanics, by applying Newton's second law or simply the momentum of equation. The force exerted by the jet liquid on a flat surface or curved surface can be resolved by applying the momentum equation. So you can see the hydropower plants, turbines, are usually utilized to generate electricity. Hence, turbines rotate due to force exerted by one or more water jets that are directed tangibly onto the turbine's vanes or the buckets. The impact of the water or the vents generates a torque on the wheel and causing it to rotate, and from the rotation it generates electricity. So the objective of this experiment it is to investigate direction forces produced by the change in momentum of a fluid flow when a jet of water strikes a flat plate or a curved surface. To compare the results from this equation and experiment with the compound forces by applying the momentum equation. Methodology: the momentum force is determined by measuring the forces produced by a jet of water impinging on solid flat and curved surfaces which deflect the jet at different angles. So required equipments are hydraulic bench, impacts of a jet apparatus with 3 flow deflectors with 90 degree, 120 and 180 degrees angle, a stopwatch for timing the flow measurement. Experiment setup: as you can see, we have a weight pen, spring, valve gauge, nail screw, target plate, nozzle, inlet pipe, and the adjustable feet. Hence, the water enters vertically from the top of the cylinder through the nozzle, striking the target, mounted on the stem, and lifted through the outlet holes in the base of the cylinder. An air vent at the top of the cylinder maintains the atmospheric pressure inside the cylinder, which is 1 atm. So this is a procedure for this experiment. First of all, remove the top plate by releasing the null nuts at the transparent cylinder from equipment and check the exit diameter on the nozzle. Then, place the cylinder and the screw with a 90-degree deflector on the end of the shaft. Connect the inlet tube to the quick release connector on the bench. Third, tighten in sequence until the built-in circular spirit level indicates that the top plate is horizontal. Do not over-tighten the null nuts as they will damage the top plate. With no weights at all on the weight pen, adjust the height of the level gauge until it aligns the datum line on the weight pen. Place a mass of 70 grams on the weight pen and turn on the pump. Open the bench bar slowly and allow water to impinge onto the target until the datum line on the weight pen is level with the gauge. Measure the flow rate using the volumetric tank, the ball valve, and measuring the time that it takes. Repeat this process and adding an additional increment until the maximum mass has been applied. Lastly, repeat the entire test for each of the 2 flow deflectors. This is the calculation method. The first one is the velocity of water leaving the nozzle with cross-section area, V equals to Q over A. Next is the force exerted by the deflector on the fluid, which is Fy. Third, applied weight on the weight pen. The fourth calculation is experiment slope of duration between W and V square. As you can see on the right, this is the flat deflector and the curved deflector with different angles. This is the results and discussion gained by from the website internet. So basically, what we can achieve is that most of the theoretical value is logical, and we can get the percentage difference value in this sense. This is the graph for the cone, which is the 30 degrees angle of deflector. This is the flat plate curve, which is 90 degrees, and you can see from the graph. And lastly is the semi-sphere graph, which is 180 degrees on the deflector. So from discussion, a loss which could be occurred, there was some of water could have not been filtered down into the main measuring tank due to the fact that the surface beneath the rig was flat. Hence, the whole hydraulic bench was also not a seal unit, so a small drop of water could have escaped. However, due to the quantity of water that was involved, this would have a negligible effect, it will not take a direct effect to the experiment itself. In conclusion, from the result obtained, the total percentage error for flat plate is slightly higher compared to the curved surface, keeping that in mind that direct comparison is difficult to make. Although the result produced were all lower than the theoretical values, which is expected due to apparatus and human error, the percentage difference from the experimental result to the theoretical is within an acceptable range. Hence, the experiment is acceptable. Thank you.